Hi, we're continuing looking at the relationship of the area of a sector of a circle with the area of the entire circle. So in this example, we're looking at an example where we have the measure of the arc, excuse me, the area of the sector and also the measure of the arc. The question is, what is the area of the circle? Circle C. Remember, you name a circle by its center point. How could you do that? How would you do that? Um, It'd be good to try this on your own, but I'm not, can't control that. I don't, if you can pause it, you can try this on your own. If not, we'll just keep going. So let's look at the way the note-taking guide is walking you through it, and then we may look at an alternative method. But we're just taking the equation. Remember, in the previous video, we looked at the relationship of the area of a sector and the area of the circle in proportion form, and also as a simple algebraic equation. So we could take either one of these two. We're looking at example 4. We could take any of these two forms, fill in what we know, and solve for the unknown. Okay, so either one of these works. Remember I shared with you part over whole is equal to part over whole, and maybe we'll look at that after we finish looking at the example of the way the note-taking guide walks you through it. So we'll take this formula, we'll substitute in what we know. We know the area of the sector, which is 22. Okay, so this is a little bit different than the other problems we were doing. And we know the measure of the arc. It's 45 degrees, the same as the measure of the central angle that forms the arc. So then we'll just use some simple algebra. The area of the circle, we can just look at that as x, or even, let's see, what do we want? Yeah, we want the area. We're not after the radius or anything. If we were after the radius, we might represent this as pi r squared, but this is just like an x. Okay, so you've got an equation like 22 is equal to 45 over 360, and that could be reduced, but we don't need to, x. So what are we going to do to get x by itself? We're going to multiply the reciprocal. We're going to multiply both sides by 360 over 45. And when we do, that x is the area. What's remaining is 176 square meters. Okay, so the area of the circle is 176 square meters. Now let's see what I have under here. Okay, all right, also using the proportion method, part over whole is equal to part over whole. The part of the angle measurement of the circle that makes the sector is 45 over the whole measure of the circle, which is 360, is equal to part over whole in area. The part of the area, which is, the part of the area of the circle, which is the sector that we're referring to, is 22. And then the area of the circle, we're not quite sure. And so I can just multiply 360 times 22 is divided by 45. Okay, or we can, maybe it makes more sense here. 360 times 22 divided by 45 is equal to A, the area of the circle. Remember, pi r squared represents the area. So that's approximately 176 meters squared. So again, part over whole is equal to part over whole. All right, and if you're into just remembering one thing, you can remember it this way, or you can remember it as an equation or as a proportion as described in here. Okay, so this works. This is basically the same relationship with circumference and arc length as well. So memorizing, one of these equations or the proportion form, and just realize that that applies to both arc lengths and area of sectors, and that can help you. Okay, so let's look at one last example. A contractor needs to cut a section out of a rectangular piece of wood as shown. So we got a rectangular piece of wood to the nearest square inch. What is the area of the remaining wood? Okay, so we're going to cut a section out of the wood to the nearest square inch. What is the area? Okay, so what's the plan? What could we do here? What would you do? Okay, well, basically we could find, so to the nearest square inch, what is the area of the remaining wood? We can get the area of the entire rectangular piece, and then we can also get this area of the piece missing and subtract, and the difference is going to be the area of the remaining wood, right? Okay, well, how are we going to get this area? We don't have a formula for an area of a shape like this. Okay, well, we're dealing with a sector. This sector happens to be a half circle. So we get the area of that sector, we can use our sector formula, or we could actually just take the area of a circle with a radius. This looks like the diameter is 3, so the radius is 1.5. Could actually just get the area of a circle with a radius of 1.5, divide that area in half, and then we've got, this is 3, and then up from here to here is 3, so we have a square that's 3 by 3. So add the area of the sector, or the semicircle, to the area of the square, take it away from the area of the entire wood, and we've got the remaining area left. Now, for demonstration purposes of learning to deal with area of sectors, let's look at the way the note-taking guide does it. So we're going to take the area of the rectangle, and then we're going to take the area of the semicircle, and the way they're doing it is using the formula that we would use for the area of a sector. 180 over 360, which is 1/2. So 1/2 times the area of the circle. Okay, so we take the area of the rectangle, we take the sum of the area of the semicircle and the area of the square. Okay, add those together and subtract from 77, and we've got 64.47. Okay, so what did we do? We took the area of the rectangular piece of wood, subtracted from it the sum of the area of this semicircle and the area of the square. Okay, these two together added up to whatever, 10.125 times pi, whatever that is. Okay, 30 something. Okay, so the area is going to be about 64.5 square inches. Okay, so what was the question that we started out with that you should be able to answer? How do you find the area of a sector of a circle? Okay, and in straightforward basic terms, you're going to take the measure of the arc over 360. That gives you the fraction of the circle that the area of the sector makes up, and then multiply it times the area of the entire circle, and what we get, that product has to be the area of the sector. But also remember, we went a little further on that, and we looked at different unknowns. What if we have where's that example? The area of the sector and maybe the measure of the central angle. We should be able to use the equation or the proportion to solve for the unknown value in the relationship. Okay, so that finishes off the lesson for the area of sectors. Now you're ready to practice on your own.